Yo, yo, yo. Sorry about the slow start. I overslept today, just woke up, so it might be a little bit slow at the start here, but let's just jump right into it. So, yesterday, like the full pipeline going from player input to the actual terraforming happening was streamlined a tiny bit, I would say. Streamlined and actually optimized in a few cases, which I like. There's still a lot of different optimizations that could be done, but we will get to them eventually. One of them was the thing we were ending the stream with, and more specifically it's this one. So this method basically alters the height map given a brush texture. So might sound easy enough. Sorry about that. What's up, coolers? Okay, let's get started indeed. But there exists a lot of special cases where I'm sorry about that one, I just woke up. Extremely sorry. Shit happens, you know. So, like, we pretty much want to take one texture and apply it to another texture. That sounds easy enough, but we might not want to apply it to the full texture, but only like a rectangle of the full texture. And even so, the height map, like so the data texture might be smaller or bigger than brush texture. There exist a lot of these different special cases basically. So the idea is to try and jump between different texture coordinate system, basically. So we have, thanks to Terraform data. Fuck, I want to send in Terraform data first, actually, but whatever. Thanks to Terraform data, we have like a nice rectangle defined with bottom left points and top right points and size, clamped and unclamped, and a lot of different stuff we're gonna use. The idea initially was to do get pixels, get pixels. So get pixels, this method calls on both textures, but yeah, I didn't really think about it yesterday. I was a little bit too slow at the end of the stream, but like this one get pixels by a start index to the index and size in width and height. And since our textures, like we will have a difference in how many pixels we will actually use in the different textures, so we couldn't do that, hence reverting back to per pixel fetch from brush texture at least. So we do terrain data colors, we get some pixels, and then we get individual pixels from the brush texture and apply it, and then we set pixels. So it's something in between. I think this is pretty much how good we can make it on the CPU when we get this working, I might add. When we have it working, I'm also going to implement a method alter terrain data on GPU, and hopefully we can do some shader magic together with Blit and see, and then we can test them, like how long does it take to alter the terrain data by doing CPU, and how long does it take to do it on the GPU. Like if we were only working with it on the GPU, like that's the only place we need it, then I would 100% opt for a GPU solution. But we need this data on the CPU as well, because we're gonna it's used by the terrain in the current implementation, and we're gonna use it for some AI stuff later on. Apply warm tea? Yeah, that would be very nice. I think I'm coming down with some nah, it's just a regular little cold, I hope. But I have a warm cup of coffee here. Should help. Gonna take a cup of tea later on. Oof, would be way nicer than coffee right now. So the problem we had yesterday, or I had yesterday, I'm gonna take the full blame for whatever shit show that was the fact that when relying on this for the terrain data and this for the texture data, like the conversion between the UVs, it was a mess because we have all these special cases. Before we jump in here, I said that I overslept this morning, so I'm a little bit slow. We're gonna open up GIMP and I'm gonna try to visualize what we're actually doing. I've done it many times now, but let's do a quick visualization. Okay, so this is our terrain. What's up, Alf? Hope you're having a nice Friday. And you too, Cooler Escape, by the way. And all the other viewers. We have a terrain by 4 patches. And let's say that... let's do this. Do we have alpha? Let's do it like this then. Let's say, isn't it Friday today? That scared me, Cooler SK. I almost thought I was had overslept one day. So let's say that we have okay, this one is one of the worst cases, I would say. Okay. Okay, so in this scenario, we assume this is the terrain consisting of 4 patches. We also assume that each patch has a height map that matches the dimensions of the actual patch. That is another problem, but I think we have it solved, so it doesn't matter. But let's see that our terraform marker is placed like this. That means that for this patch, we want to alter this square. For this patch, we want to alter this. For this patch, we want to alter this. And for this patch, we want to alter this square. A lot of special cases. I guess the easiest one... I don't even know which one the easiest one here is. Maybe this one, to be honest. All of them are hard. But, so, through the pipeline, we're gonna get a terraform data that represents this square. So we have a bottom left point, we have a width and a height, and we have a top right point. We have some other data as well if we might want to use it. So we have the pixels of the patch data we want to alter, but now we want to get the pixels of the brush texture. And the brush texture is defined by this marker right here, which means that when we alter this patch's height data in this square and we want to get the pixels from the brush, we don't start at 0, 0. We start at 1/3 in the x direction and 0 in the y direction. And we don't want to go to 1, 1. We want to go to 1, 1/4 basically. And when we alter this one, we want to go from pixel 0, 0.5, but they are size based. So let's say that this is 32 times 32 maybe. We want to go from 0, 16 to, what could it be, 14, 32. So you see, like, it's not as straightforward as I would have hoped, but it shouldn't be that hard either. Much thanks to the fact that when we get the pixel from the brush texture, we can actually rely on normalized coordinates. So the full coordinates for this pixel is independent on the size of the brush. We just have 0, 0 in this corner and 1, 1 in this corner. So what it all comes down to is converting the pixel coordinates of the patch texture to the correct normalized UV coordinates for the brush texture. Luckily, the terrain data has a UV start variable, so a float2 with UVs where we should start, and I'm like 90% sure it's correct. So we already have a vector 2 that is 0, 0.5. We just need to figure out first like how many steps we want to take related to the pixels of this height map, and how big the steps are in normalized UV coordinates. Cooler SK, time to attempt some freedom. Not entirely sure what you're referring to. So, this conversion is what we're trying to do here. So, at the end of yesterday's stream, we had something like this. We go through each pixel in this one, which we have gotten. Unfortunately, one-dimensional index. Oh, you're gonna do some Helldivers. Is that it? Love it. So for each pixel here, we have a one-dimensional index. So we have two problems. We need to also convert it to a two-dimensional index. And we did it like this. So we do the UV we calculate are UV start plus trying to convert this index into a two-dimensional index for each direction, and then multiplied by UV step size, which we actually have in Terraform data. And I'm like 80% sure this one is correct. Maybe you should help them with their own Fire servers. I don't have that much server experience, to be honest. And haven't they been working pretty nicely for the last couple of months, or do they have new problems as well? So, I'm pretty sure the problem here is that when we convert this to a two-dimensional index, here we use the wrong reference rectangle, basically. I think we should be using... So currently when we transform it into a UV coordinate, we do it using this patch full width and length, and which means that when we convert it, yeah, and that could work, but this one actually starts from 0. So what we want to work with here, I surely hope this is the correct approach. We want to base the conversion between one-dimensional index to two-dimensional index on the actual rectangle in Terraform data. So it would be something like I think we want Terraform data dot size clamped dot x. Oh, they have openings for IT engineers. Yeah, and I think it's the Swedish studio as well. The community is mostly content, yeah, except for that Sony stuff happening a couple of days ago. And I haven't actually looked into the latest balance changes. Like, I mean, it's basically a PvE game, right? So you would think people are more lenient with balancing. Balancing is more about like meta shifting than anything else. So instead of having to run around with weapon X, you have to run around with weapon Y. They nerfed the OP gun that everyone was using. Which gun was that, by the way? To be like, I 100% always run around with autocannon, I think, and some shotgun. Eruptor, okay. So, by the conversion to two-dimensional index should be done by this instead of the previous one. Let's just try it and see what we have. It was primary that shoots explosive mini rockets. That sounds pretty nice. Oh well, now I guess the community will have to find their next OP gun, if it exists. But I like the fact that, like, there shouldn't exist one. I like the fact that you base your loadout more on, like, preference and not what's the meta, so to speak. Okay, so if we alter this one, the current brush we're playing with is this one. It might be hard to see, but it's like a circle gradient. So we should almost be seeing something like this. Almost. We're still okay. Attempt to divide by 0, that's not good. Ooh, we're almost there. Yeah, and I think the problem we're having here is... yeah. Trying to divide by 0. Size clamped in our Terraform data is actually... we want to include the last step, so I think this might be what we want to do. It had shrapnel component to it, which dealt crazy amount of damage. And kill the user every now and then. Hey, that sounds like a fun weapon. Nice. Good morning, Geralt. Hope you're having a wonderful Friday so far. And what's up, ArtDev Life? Thank you so much for the raid. Hope you had a productive stream. Oh yes, here we go. I think this might be it. Small steps, honestly. Hey, small steps are steps, right? How's Terraform going? It's going pretty good, I think. We have streamlined and optimized it a tiny bit, and now we got it working with the more optimized approach. So I like it, I like it. And it's looking really good. Thank you. I think so as well. I think so as well. But nice indeed, thank you, Auf. But like right now we're doing it on the CPU, and I want to implement it on the GPU as well. I want to compare them performance-wise. But like, let's try this. 1028. Admittedly, I think community is just butthurt because everyone wants to be a hero, and that gun enabled that. Yeah, that could very much be the case. Okay, I get this. Or do I? Yeah, I think I do. I actually love the weird bumps you get by this. I'm not a big fan of this right here, but that's just because of the strength of the so let's do brush strength. We have a brush strength of -1. Let's go minus 0.2. That looks better. Okay, and when this, with this resolution of the terrain, we can actually see some performance jumps. But that's okay. Like, even though we can't optimize all of that away, we can just hide it. We can offload the work to a separate thread, and then we hide the calculation time behind some nice animation, right? Like the terraforming won't be instantly either way. So the character is going to have a shovel, and he's actually going to put it into the ground, use his body force, and destroy the ground, pretty much. So we have plenty of time. Like as long as our animation isn't more than like 2 seconds, because I think that would be annoying to the player. But we at least have 1 second to do the work, so it should be okay. The thing is, it wasn't even support weapon, and it was more powerful than most. Yeah, it kind of sucks when you have a primary weapon that is better than a support weapon you actually have to call for and that has a cooldown. So yeah, I could see that change. Although, oh yeah, okay. So something to keep in mind here is that we're actually altering. Let's see. I think we still have this data. We're altering a Terraform data. We're altering a area that is 38 times 38 vertices big, but we're doing it with a 16 times 16 brush texture, and I think that's why we're getting this. Would call it, yeah, uneven. Alteration of the ground, but like, still doesn't look too bad. Yeah. Yeah, we're gonna have to add... I have some things to think about when it comes to gameplay. Like, would I allow for something like this? So like a sharp line. So here we're at the lowest possible height of the terrain. So you get these sharp edges. I'm gonna have to do something about that, or not. The idea is going to be that if you dig deep enough, you're gonna get water. And that's basically how you're gonna have to... the way you're gonna do lakes and, I don't know, rivers is going to be hard to support, but some kind of river. Maybe a river with no water flow whatsoever. Yes. Do I dare try to implement this in on the GPU? I think so. I think it looks good. Although I would opt for a material that isn't as shiny as this one. But yeah. Okay, let's see. Big fan. I think this looks good. To be honest, we might as well do this. I'm gonna do one more thing before we continue. I'm gonna alter the terrain material a bit. We're gonna have these big red lines, but we're gonna change them to white, I think. And I'm thinking of adding a tiny grid to it as well, so we can actually see the grid without having to go into scene mode. I should have done a lot of these things from the get-go. Would have made things a little bit easier. I'm a big fan of this. Okay, so yeah, I think I have converged towards a to-do list today. Let's see. Implement terraforming. Implement Ooh, this one. Actually square. I'm actually gonna do it like this. So actually, let's call them by the name. So auto terrain data let's just call it GPU for now. So this is what we're gonna do first. And then we're gonna do implement, and then we're gonna do action terraform dot brush strength. Implement the possibility of changing brush strength in game. Might need to restructure this a tiny bit, but in fact I want to implement the possibility of changing action terraform brush texture in game, and create various brushes. Yeah, and we also have one issue I want to show you, which we noticed yesterday, unfortunately. And that problem is basically concerning this one, but not really. I'm gonna show it. Okay. So let me just put it here easily implement custom rect struct. That's done. Implement GPU alteration of height map. Fix issue. Fix terrain patch filtering issue. This is the one I'm gonna show. Make it possible to alter brush strength and brush texture in game. Does it exist? Like, it would be nice. One sec. Get GitHub issue or show GitHub issue in VS Code. Someone should have done this. That would be amazing. Is this official? Okay, show it like this. Oh, open issue, what the hell? How fucking nice wouldn't this be? Like, I would love to have my issue here, maybe. Wow, that would be amazing. Just gonna add that to my off-stream to-do. Sorry about that. That would be nice. Okay, so moving on. This is pretty much what I want to do today. So implement GPU alteration of height map. Hopefully that one will be much cleaner than this. So basically we're gonna do... Here we set terrain data by a new data. So we're basically going to do something like this. Unfortunately, we also need to do this. So we need to send the data back to the CPU because we need it on the CPU. So temp data container, although set terrain data. Would have loved for Texture 2D to basically contain, like, if you could work with Texture 2D as you would a render texture. Texture 2D inherits from texture, render texture inherits from texture. Are we actually going to have Unity split with texture 2D? Temp render texture, yes. Okay, so I guess we're gonna have to do something like this. Let's see here. Data render texture. Are we gonna have to keep track? So we're gonna have a texture 2D data exists both on CPU and GPU. Then we're gonna have a data render texture only on the GPU side, and we need to always sync these two. So the important part is that we sync them in set terrain data, which we already do. And then we do it here, we do it here. Okay, nice. So we already sync them basically. But we also need to sync them here. So that would unfortunately lead us to having to do something like and that is if we want them synced. So like if we only rely on this one, if we eventually only rely on this one doing the work, the heavy load on the CPU, then we don't need to sync the render texture. If we opt for the GPU approach, then we are going to sync the render texture either way. So I'm just gonna leave this one here. I definitely don't want to do it if we're gonna measure performance later on. I definitely don't want to do it now, because basically syncing the render texture here would 100% make this one slower than the GPU equivalent. So let's see, yeah, let's just dive into this. I'm anticipating a lot of problems here, just want to add that note. So alter terrain data, GPU. What's up, Amena Pro? And also, if we opt for this solution, we are going to have to give it a shader, so a material reference as well. We basically want to do the blit with a material. So this is basically going to be this material brush material. And alter terrain data GPU. Actually, I'm thinking of storing the brush material in Terraform data, if I'm gonna be honest. Or. Yes, because we're gonna add a lot of. Basically what we want to end up doing, and Amena Pro, I don't know if I answered, but it's no problem at all. As long as I remember it's not multiplayer, right? Yeah, it's single player with the eventuality of multiplayer. We'll see. So basically what we want to do here is graphics.blit brush texture data render texture, and then we want to send in brush material, and then we want to do this, but we don't want to do it like this. Read pixels. We want to do it with I think we can do Emena Pro, why don't you want it to be multiplayer? It's not a question of that, honestly. It's just... First of all, I'm a big fan of single player games. But I'm also a big fan of like co-op games, you know? It's more about minimizing the scope of the game. Adding multiplayer to a game is a huge scope extension. Yeah. So basically we want to take, when we read the pixels back to the heat data on the CPU side, we only want to read back the relevant ones. So it's basically going to be a new rect What do we have here? Rect source, destination X and Y. Ooh. And the source is data render texture, which is the same size as our height map. So yes, we can do new rect. Basically we want a rectangle to look like this and this. But when it comes to source start here, it's this one and this one. Jesus, what a mess. But so basically we do a blit, brush texture into data render texture using whatever shader we have for this material, and then we read the pixels back to the CPU, but we only read the altered pixels, because even though we're going to do a blit with this full render texture here, we only care about the actual altered pixels. Like this is going to be the biggest problem here with the blit. Brush texture is like this one and this one are going to have different sizes, so we're going to have to handle that in the shader. And most probably this one will always be smaller than this one, I would assume. Yeah, in the end that is going to be the case. So alter train data on GPU, do the blit, do all the calculations on the GPU, which means that we might do some very cool stuff in this shader without much of a time loss. And then we read the pixels back to the CPU, to the data texture, and then we send that one to the GPU representation of the data texture. Yeah, it's a little bit of a mess, but I think, all in all, I think and hope this will be quicker than this, depending on the size of the Terraform data, of course. Let's see, in Unity, if you want, there's a count sample. Oh yeah, I have no doubts that there exist a lot of very nice packages, both first party and third party, on the Unity store. Emena Pro, yes I am. Yes I am. So, my experience with blit has always been blitting one texture into another texture where both of them have the same size, which have made it extremely easy to work with it in the shader. That is not the case this time around. So yeah, what do we want to do first? We want to do, let's see here. I want to debug shaders. Let's take world normal shader, duplicate it, and then we have functional shaders here. Random color based on vertex color blue. Yeah, and we're gonna call this one Terraform shader, or actually Terraform height. Terraform shader. Functional shaders. Here we could actually make this shader rely on, like, what is it, blend commands. So instead of having to read both source and target textures, we could make it depend on doing the blending with the blend commands, but I'm gonna hold off on that. In Mana Pro, what will be game currency? Oh, that is an interesting question. I've thought about it a tiny bit, but like, we're probably just gonna go with gold coins or something like that. Unoriginal. So, when we work with Blit, am I thinking about this correctly? Let's see. Let's take a look at graphics, Blit, Unity. And Mana Pro and the image. What you mean, the currency image? I don't know. So So it passes source to the material as the main text property. So we have it here, main text and main text st. I wonder if this is the scale and offset. We'll see. Uses the materials shader to draw a full screen surface from the source texture to the destination. A little question mark about this. So are we going to work with the textures? First of all, we're going to work with the textures using UV coordinates normalized. But is it going to be related to the full screen? Like our ratio, like the full screen of the game? Or is full screen based on the source? Or I mean the destination texture. In Mana Pro, how long do you plan to make this game? Right now I wouldn't have any complaints about doing it for a long time. But would love to have like a vertical slice ready. Next year maybe. And this I know all about. This is something we might have to keep in mind. So we want to work in linear color space. We definitely don't want to work in sRGB. We're working with data here, so we want it to be linear. But, like, to make sure the sRGB to linear color conversion is what you expect. Like both the source, or actually the destination is most definitely in linear color space. The question is about the source, and I wonder... Yeah, we will probably just unclick this one, which means that both the source and destination will be in linear color space. So I'm really questioning the need for this one, if that's the case. Emena Pro, not at this stage. But thank you. Appreciate it. Like, ideas are generally always welcome, that's for sure. Okay. Okay, I don't care about this. I don't care about this. Would love some more information here. But we had some nice... we have some nice tabs open here. This one. Okay, textile size. Here we go. Oh, yes. So in the game you can kill mobs and creatures. No, I'm not going to support any... Not directly killing, I would say. So you won't be able to go to a creature and kill it with a tool or something like that. That's not going to be supported. But like, if you neglect your creatures, they will eventually die, unfortunately. Okay, so here comes a very important thing, I would say. So this might be the wrong way to do it. I honestly think that we want to do... So right now what I've done is that we take the content of brush texture and we blit it into data render texture. But I wonder if the better way to do it, because right now with this approach the material, the brush material or the shader will run for as many pixels as the destination has. I would love to only run it for the amount the brush texture has. The The question is if we can do read pixels back nicely, because that would pretty much mean I think we can do it. Or MNO Pro, the opposite of hostile friendly creatures. And like, yeah, I like the idea of going crazy with the currency, like not going with the usual uncreative coins. But we'll see. That is a few months ahead, at least. So the only problem I can see with flipping these around, this read pixels back is still going to be read pixels. Because, let's see here, this one, you're running into a 512 RT, so it's going to run 512 times 512 times. I want to minimize the time it runs, so having the brush texture as a source would probably be the best. So basically you would have the brush texture, and you would on the GPU write the altered height terrain values to the brush texture, or to the render texture of the brush texture, and then you read that back. So we would have to do a custom class here for brush as well, Terraform brush, which hold both a texture 2D and a render texture, and do some work there. I think that might be nice. And if we have Terraform brush, a custom class, we can also push this into that class. Yeah, that's nice. The only big question mark I have right now is how much read pixels back here will be, how fucked this will be. May I ask what's brush texture? So brush texture is a texture describing how the height map will be altered. So it might be something like this, which means that we won't alter these height values, only the ones in the middle, and we will alter them with a strength of 1. Or you could have this, which is, I don't know how visible it is on stream. But it's more of a gradient circle, you know. So read pixels here when we read them back, because we're gonna have a mismatch in basically when we read it back. The rectangle here defines the source, start point, and end point in pixel values, absolute pixel values. And then when we have destination X and destination Y here, that pretty much implies that we have the same size, which is unfortunate. But let's see here. Texture 2D, what did we do? Read pixels. So this one is the one we rely on. Do we have... Yeah, that sucks. What's up, Tough Eye? Hope you're having a great Friday. So far, how's life? It's pretty good. Overslept today, so a little bit slower than usual, but starting to wake up slowly. Yeah, like this one is a little bit of a problem. Because this one basically relies on this one pretty much relies on the render target having the same size as the data, or does it? Or does it do some magic behind the scenes? Ooh. Ooh. Didn't I have an optimization? Maybe not. Use instead of texture 2D dot read pixels. Pass the data from GPU to CPU. Imena Pro, hey, if it helps, I think you can debug print it right. Yeah, we can. Definitely. But yeah, okay, so this GPU approach here, we might have hit a wall here. Only due to the fact that this one probably works under the assumption that source and destination are the same sizes. Okay, I get that. At least they are in the example as well. Yeah, this is interesting. We might skip this as well. with our current implementation. So we might not even send it back to this. Never mind. Nah. Yeah, so here we send it back to the GPU as well. Yes, so we might want to skip this. But the problem is still here. What I'm getting at is we might want to alter a rectangle that is 16 times 16 pixels on the source, or actually on the destination, but the source might only be 8 times 8 pixels. Which means if we do it this way, however, then it's okay, because this data render texture is the same size as this one. So then we can do this. It's just if we would have opted by having brush texture as the source. So what it becomes now basically is we're gonna run it for the full height map for all pixels. What's up, Skulltag? Good morning, good morning. So doing it like this means that we can do it like this, and then we might not want to do this. So it would look like this. But then again, yeah. This blit will change data render texture on the GPU, which will hold the data values. So I don't think we will get a desync between this one and this one. Managed to fix that issue we're stuck on yesterday? Yes. Like, the problem was what I said at the end of the stream. We were changing the one-dimensional index to a two-dimensional index based on the wrong width. So instead of doing what did we do? Data.width here. It should be Terraform data size clamped x plus 1. So basically the rectangle we base Terraform data on. It should have been pretty straightforward. So alter terrain data works, but this is CPU only, right? And we just started dabbling with the idea of doing it on the GPU, but there's a lot of decisions to be made. Like, but it should be okay still. Okay, let's continue with it like this, and let's focus on the shader. Basically, oops. Although we do want to read in the shader, depending on how we do it, we want to have if we opt to not do it with the blend commands, we want to be able to get the data from brush texture and data render texture, both. But then again, we have a lot of offsets and stuff like that to think about. So basically what we want to do is here we have this one. Yes, you want to do something like this. Emana Pro, feel like it will take 2 weeks to do that. You're doing terraforming right? Yes, we are. Yes, we are. So this is basically what we want to do. We have a big texture, we have one smaller texture, and we want to apply it on at a specific position of the bigger texture. Yeah. Scale offset. I would like to be able to rely on scale and offset here, but we might... I like setting them myself. But if I remember correctly, we get it here. Okay. So the only problem is basically going to have to get the tiling and offset correct, and we're also going to throw away a lot of pixels. So like I think so we will run the fragment shader once per pixel in the destination texture, and like the majority of those won't be affected by the brush, so it will just be a check in the fragment shader and then don't do any changes. We won't, I don't think we will. We'll see. Okay, so what I would like to do is, yeah, let's do it. Brush material. Yeah, let's do it like this. We might be able to clean it up. But basically, we can do we have the main text here, which should be the source. Oh, it would be way easier to rely on blend here. First of all, let's see if we can get the correct pixels to alter, and then we can try and decide how they should be or implement how they should be altered. So at first we're just gonna return black here. I just want to see so we get the correct rectangle of changes, basically. That should be pretty straightforward, I think. What do I want to keep properties here? Yeah, we can do we don't need normals and tangents. We don't need this. We just need this. So here it's a simple... The vertex shader for our blit is just going to be... So if I remember correctly, blit pretty much creates a screen quad. So the vertices are 4. And we just want to position CS. Though, if we rely on this one, it should be okay. Good morning, Harukanan, and happy Friday. I think we should be okay with this, but we will see. So, to make this as easy as possible for me, we're gonna do let's see if I remember the syntax here, but let's do UV offset vector is equal to 0, 0, 0, 0, and do I want... So basically, when we do the blit for this patch, for instance, the UV offset should be 0 and 0.5, so we start here. For the question I'm wondering, do we need... Yeah, we need UV offset for source. We need UV... I wonder if we want to go with UV start. UV start and UV... So UV bottom left, UV top right for both of them. that how I want to do it? Definitely want that one. And I think, and basically it comes down to UV start, UV end. So in Fragment we could probably do something like if we were to rely on blend, we're not going to do that right now. Let's do and then we have one of these. Let's see here. Although UV end is including, I think. Could we do it like this? Okay, let's do if is within bounds. Actually, so so the idea is to send in the UVs of the rectangles as UV start and UV end for the source texture. This is. So if we are within those, we set the height value to 0. If we are outside, we set the height value to 1. Pretty straightforward. So if we then do terrain patch terraformer, update vertex data using terraform data, instead here we could do, I think we should have a method called or don't we? I thought we had. Okay, that's unfortunate. So what we could do is, yeah, let's do generate terrain data. So the idea is that we use alter terrain height using Terraform data. Brush material, yeah, of course. Actually, okay, so the idea is we call this one, let's see here, terrain patch terraformer. Let's call it Blit instead of GPU, to be honest. Texture 2D, Terraform brush texture. Okay. Oh, it didn't change here. Okay, Terraform data Blit. So if we go to Action Terraform, here we do this. So let's do Actually, that's not it. And yeah, we need that material here. So let's go brush texture, brush strength. And here we do update full terrain data. Okay. Still need to set this material up here on the top. Yeah, let's do that first of all. Oh yeah. Okay, so that's all for the setup, I think. We're also gonna do or do I want these? Let's show them for now. Whatever. We need to set these, and then we should be able to try this. So what do we have? Alter terrain data blit. First thing I'm gonna do is terraform data. We have UV start, we have UV end, oh yeah. And I think they are correct. So we can do... Definitely want to create a custom class later on where we have both of these packed into it and we can rely on less... What is the term? Magic strings. But basically what we want to do here is brush material, set vector, and for now we're going to do it like this. UV start, terraform data dot UV start. and brush material, UV end. So we set these two, then we do a blit from brush texture, but we don't care about that one currently, but we do it to data render texture using brush material. So now we have the new data in data render texture. What we do then is we read the hopefully the relevant pixels back to data. And we don't need to do this, I don't think. So now we have the new information in data. So when we do update all vertex data, we do it with the new height map, and we just change the full fucking patch. So if this works, before I try it, I'm just gonna go through the pipeline once again, or from the start to this point, just double check so everything is set up accordingly. But the result we will get is that we will alter at the marker, we will set the height to 0. Everywhere else on the patch, we will set it to 1 currently. So we will get a big jump. I wonder though if just to make it easier to debug. So right now we will generate some terrain based on a Perlin noise map. So we'll have this nice terrain we have. And once we do the first terraform, we will fuck the full patch up. So almost all vertices will jump to a height of 1, but the altered square will jump to 0. But yeah, just to make it a little bit easier, we might do something like terrain patch, or actually terrain data container. We have a function here called here we generate the value, noise, set terrain data, noise texture, yeah, we don't do height range. I'm gonna have to go to I don't want to change too much here. So just return a texture with pure white. Okay, last thing, action terraform. So what we do here is we do have a brush material now, which I've set. So when we actually do the terraforming, we do everything we did previously, but instead of this, we do apply terraform brush blit and then update full terrain data. Let's see what we have. So what I want to see is I want to see a terrain generated with an even height all over, and that height will be 1. If we apply the brush, we will change those coordinate systems to be 0. So basically, that's fucking great. That is perfect, I would say. Okay, can't do it here for some reason. Yeah, we get this, but that's to be anticipated. So in the X direction, might know what is going on here, but might yeah. Okay, apply terraform brush blit. We do know that using the terraform data has worked previously. It's just specifically for this method right here. Alter terrain data blit. With the UV start, UV end, we do less than or equal to. We do +1 here. Oh, watch it end. What's up? What engine are you using? I'm using Unity right now. 21.2, I think. Okay. Let me try one more thing though. This is a little bit weird. And I also find it weird. Whoa. Yeah, okay. I would have thought that changing the terrain here would remove the other holes. But no. Could this... Okay, it's weird that it works here as well, but not in the X direction. So only in the X direction. Yeah, we might want to do this during testing. Read pixels 0 0. Ooh, terraform. Yeah, this... Yeah. I think this is correct, but let's go with... What is it? Bounds. Yeah, I think we can do data.width and data.height. So we change a small part of the data render texture, but we read it all back. So now we should see a reset in so if we put a hole at one position and then we do it on another position, we should see the full patch reset, I hope. Whoa. Okay. So we actually set this one, all of it to 0. Which basically means that this check isn't working. And the result we just recently had is only because of reading a portion of the new data. Brush material is set to the correct one. We have it to Terraform default material. We have UV start, UV end here. Is this just a matter of this one not being set, or is there something else going on? Or are we gonna have to calculate these ourselves? Oh, yeah, I wonder. Let's see what solution here. Don't we have shader? Yeah, it should be. We should be getting the UVs here. But then again, yeah, we should be. Should be okay sending it in like this. So set vector, which will convert these to vector 4. Brush texture. This one sets the render target, this one reads from the render target. Do we need to do apply? No, shouldn't need to. Yeah, I'm having a hard time pinpointing. Start. Let me just try and do. I think this is quite faster, to be honest. But okay. Check name seems to work. Are these not getting passed accordingly? Or in the correct way? We set UV start and UV end, and I'm pretty sure these are correct. Terrain patch. Using Terraform Blit, Terraform data. Yeah, and when we create those, Terraformer, we call get terrain Terraform data, so nothing has changed there. Update all vertex data, brush Blit, Terraform material. Actually, we can do this as well. So if we take a look at this one, we have a Terraform data. We have a UV start 00, UV end 11. Yes, of course. Of course. Okay, my mistake. UV start and UV end has always referred to the brush rectangle, pretty much. So the UVs we're getting here are the UVs for the brush texture, which we're eventually going to send in as well. So if we put it here, we have, for the first one we have 1 1, or okay, for this patch we have, let me double check. For this patch we have, so it's this patch. We have. One sec, is this even correct? Yeah, yes. Okay, for this patch, or for this patch, we have There we go. Yeah, for this patch we have UV start at 0 in the X direction and ends at 0.5. But our UV end is actually 1. Actually, UV start we have 0 and 0.5 in the Y, so that's correct. UV end we have, I'm looking for this patch. Okay, now I think I got it. For this patch we have UV start at 0. Jesus. UV end, UV start 0, 0.5, UV end 1, 1. So we have this little square here. Is that how we want to do it? Or actually we have so it goes from 0 to 1 in the Y, in the X. I'm not entirely sure that is correct. 0, 0 to 1 and 0.5. Okay, that's wrong. Or actually, no, it's not. 0 to 1 and 0 to 0.5. Yes, okay, so the white dots are the texture indices we actually want to change. So for this patch we should be having a brush UV of so for this patch we want to alter this point, this point, this point and this point. So we should actually have a UV start of 0. So 0 and 0 to 0.5 and 1. So I guess it's this one. No. 0, 0. And 1, 0.5. Okay. Jesus, what a mess this is. We start at 0.5 in the Y, but 0 in the X. And we go to 1, 1. Okay, so this is correct. The second one we start at 0, 0, and we go to 0.5 in the Z and 1 in the X. Yes. Okay, so the UVs we get in Terraform data, or which I've calculated in Terraform data, are actually the UVs for the brush texture, and we're gonna need those as well. And they are being calculated correctly. What we need now is bottom left UV and top right UV, but we want bottom left clamped UV and top right clamped UV. It's a lot of data, but it would look something like this. Terraform data, UV start, definitely want to rename these, that's for sure. So these are pretty much going to be I don't want to introduce the terminology brush here. So bottom left vector2int and top right vector2int, they define a rectangle, and these UVs are relative to that rectangle. Do we have the full? Yeah, we're gonna have to go with bounds here. Okay, let's see. I want to do something like UV rectangle space start. And we're unfortunately going to need public vector2 UV bounds space start. I'm not sure about the names of these, but so UV relative to bounds, UV relative to some rectangle, this rectangle. Let's see, and we want these to be clamped as well. And actually UV rectangle space step size. No. Bounds dot inverse lerp can we do bottom left clamped dot x bounds inverse lerp bottom left clamped dot y bounds here is the bounds of the patch including the last pixel. So basically if the patch is, I think, so if the patch is 256 times 256, bounds is 0 and 255, which means when we do inverse lerp on that, should do it like this. So zero, 0 will lead to 0, 0. 1 will lead to the max of bounds, so 255 in the previous example. Yeah, so this is 255, which means that this will be 1. Yep, something like this, I think. So we should actually be doing... And then I might want to rename these here as well. Or actually, maybe not. But dot UV bounds space start and bounds space end. And yeah, let's do this for now. If this works, we revert to this. And I actually want to see what kind of values we have here as well. So for instance, if we put it here, yes, we have the nice rectangle spaced still. They are the same as previously. UV bounds though. So let's take a look at, we should have, I think we have 16 times 16. So let's get that calculator up. Then we have 0, 1, 2, I think, so 2 divided by 16. So we put 125. 2, actually, 2 divided by 15. So 0.13, and I think I recall seeing that. Yes. So begin in X at this one, end at this one. So that's half, that's plus. Okay. Oh, actually, it's correct. So we actually have 1 divided by 15. One step is 0.06, 0, 0.06, 0.13, 0.19, 0.26. Okay, I think those are the correct ones. Okay, so now, like, if this is the correct way of calculating it, we now have 2 set of UV rectangles defined in Terraform data. One for the brush, one for the height map. That's pretty nice. And did we get the correct one there, or did it... Do we have... Doesn't it look like it's shifted one step? Oh, that's hard to see. This one didn't seem to be shifted. Oh. Are we having rounding point errors? Maybe. I think we do. Why? Okay, we're not including everything. Okay. UV bounce space start, UV bounce space end. UV end here can actually be 1 less than or equal to 1. Yeah, we want to do it if it's 1. So the only culprit I can think of is this one. UV bound start space start. Bounce. Get Terraform data. Bounce in question is patch bounce. Resolution -1. Bottom left clamped. I think it's these we want to go with. But UV space start, bottom left clamped. Yeah, we might get I think this is how we want to do it. I don't see honestly don't see but if we take a look at this one, yeah, it's offsetted. Yeah, something is amiss. Here we get, now we're still not getting the correct. We should be seeing, yes. Okay. Yeah, we should be changing with this approach, with the current implementation. We should be changing. What is it? 9 vertices, I think, or 9 height values, but we're getting just 4. Yeah, we go 1 less than we should in height and 1 less than we should in width. But it works sometimes and sometimes it doesn't. Is that a... So in this case, for instance, we go the full length, the full width, but not the full height. Floating point precision error question mark. Yeah. Triangular madness indeed. I wonder if, yeah, when we get a UVX that is equal to UV end, we might skip it. Zero should be no issues, I don't think. But here I wonder if we want to do UV step size. Wonder if this will fix it. I'm gonna try it still. So I think worst case scenario, this one is equal to this one, but there's a little bit of a float mix up. So we want to add an error here. I think like UV start might, yeah, that might suck as well. Yeah, so I think we want to do UV start, UV end, UV step size. Okay, so we need to set this one as well. We need to instantiate it here. So much like we have UV rectangle space step size, we want a UV bounce space step size. And this one is honestly just equal to 0.1.0f divided by bounds dot max bounds range. Oh, don't we have access to those? Public float min max. I think. And then of course okay, return and could this be it? I hope it is. Oh, here it worked. Interesting. see. Could be a possible set of things. Not entirely sure. Let's put it here. So for this one, I think it's element 2. That is the one we are interested in, yes, because it goes from 0, 0 to 1, 1, so the full rectangle is within the patch. What kind of bounds space UVs do we have for this one? Element 2. Start at 1 in the... Ooh. I might know what I have done, maybe. Because this looks... wrong. Step size... Let's see if step size is correct at least. 1 divided by 16. Yes. UV bound space start at 1, 0. Nah. Depends. Oh, it's actually... Oh, yes. It's element 1 that is our correct one. Because here we have 0, 0, 1, 1. We start at 0 in X, that's correct. And we start at 0.86 in Y, so that is max Y 1 minus... Seems to be correct. And we end at 1.13 in X, that is correct. And we end in 1 in Y, and that is also correct. So these are actually correct. Space start and end are correct. So what do we get if we... We alter, yeah, not the first ones. We want to alter this value, this value, this value, this value, this value as well. So these are correct, I think. So it's these two that are missing. Actually, it's these. Oh. The first one of the y's and the last ones of the x's. What? UV end, UV step size. Yeah, one sec. My question is, would this change? Now we make the step size bigger, or yeah. But let's see that we have 4 times 4 vertices. That means that the bounds here is 0 to 3. 0. Yeah, this is how we want to do it, but I don't see how this would fix it. But that's not gonna stop me from trying it. And then we get 1. This is... we get a 4. Get a 1. Yeah, okay, so it's definitely something with the check being done here. I'm gonna see if I can solve it, but before I do, I just need to get something to eat real quick, so be right back, 5 minutes. Okay, back. What a mess this is. But it definitely seems to be although, yeah. Sometimes we get the full range in the Y direction, sometimes in the X direction, and sometimes in neither. And the only place this is handled is here. We do calculate these outside and send them in, but then we do this check here. So if UV is bigger than UV start minus UV step size, and it's less than UV end plus UV step size, and then we do the same checks for Y. Oh, it's so close to being correct, but is it always in? As soon as we don't, or as long as we don't get extra vertices, I'm okay. What the hell? UV step size. I was pretty certain that this offset would fix the issue. UV bounce base step size 1 divided by, this one is float, right? Yes. Divided by float. Ooh. Now I want to keep it like this, and we do set it here. UV bound space step size. Float 2. That shouldn't screw us up, I don't think. But. Yeah, the problem could be, like, if I understand this correctly, I'm not entirely sure here. The question is how this data render texture is represented. Like, if could it? No, it shouldn't be. Like when we do a blit here, data render texture. Oh. I wonder. I wonder about. I wonder about this one. More specifically, about this one. Oops. So, yes. We might want to scale the UV step size. Blit should set this variable for us. So yeah, I'm a little bit worried about this step size not being big enough. So if we, let's say that we are in UV screen space, whatever you want to call it, with the UVs, this is not enough. I wonder if float 4, if this is the correct term, we're gonna have to check it up. But like, I wonder if we want to multiply this one by the scale we have in here. Because what I'm getting at is that we do a full screen blit, so the width is, the absolute value of the width is bigger than the absolute value of the height. So the UVs might be a bit skewed. I don't know. I hope that's the case. Do we have some reference to this one here? No, we don't. But let's see. Float for textile size. Oh, do we care? Do we need to care about this as well? That would definitely suck. Like, I want to know the structure of textile size here. But you're bleeding from a... We'll always draw a full screen rectangle, yeah. So UVs are a little bit weird. Thought we had... Yeah, I think this is the problem. Okay. But so either we rely on textile scale, but that's only the scale, not the offset. So I wonder... I wonder if it's enough to do... I do want to try this. Let's do UV input UV multiplied by textile size. Maybe. I don't know. A little bit worried about the eventual offset as well. Okay. Or actually, no, that's not how I want to use it. I want to use it... bleeding from this texture, and that's what you will get in main text textile size. Yeah, we're gonna have to work with this one later, I think, but not now. But I still think okay, so textile size is related to the source. We don't care about that at this moment, but we do care about like, I'm still wondering if step size. Yeah, what I'm thinking is, let's see here. Unity screen params in shader. What can we use here? Screen params, X is the width of the camera, target texture in pixel, Y is the height. Z is 1 plus 1 divided by width. Okay. Can we use this one, or do we need to include something? What I'm wondering is if we want to do something like don't think so. Or let's see here. What I'm afraid of is that UV step size here is too small, at least in the width. Actually, it should be too big, which would make this pass. Are we working with... If the offset is wrong... Should be okay. Like, we shouldn't have to worry about this until we actually start using this one. I don't think. What's up, Meister K? How are you doing today? UV start and UV end should be correct. UV step size is correct under the assumption although UV here, could we seeing the issues we're seeing if UV here is it shouldn't be good. Nice. Same here, same here. A little bit perplexed by this current problem we're having, and yes, more terraforming today. So we actually have the terraforming working with various brushes on the CPU. Like if we do the height map alteration on the CPU, we got it working. I wanted to implement it now on the GPU because I have, it's probably faster when we change more values, and I want to compare the two, like what kind of performance do we get doing it on the CPU compared to doing it on the GPU. And the approach we chose on the GPU is to rely on a graphics blit call, and this one basically takes this texture and adds it using this material to this texture. The little bit of a problem we are having though is that this one is a different size of this one, so we have a size difference, and this one is usually smaller than this one. But like when I reiterate the problem we're having, the more I understand that it's actually exactly this problem we're having. So we should be able to use this knowledge we have here. Although he's working with a sprite, nah, should be okay. Main texture scale and main texture offset. Main texture is this one, so we don't really care about these right now. Ooh, okay. But it's in the UV space scaled by the texture scale. Okay, let's see. So let's take a look at this one. So this one basically, I guess we have okay, we blit the background to the render texture, so I guess that's the rainbow texture we have here. And then we have a there's a little bit of logic here we can skip, but... Or actually, the problem here, I think... It seems like... Let's see. Okay, sides is... Texture 2D beautiful. So sides is probably these numbered squares here. So we do sides index RT blitmat. Scale offset. We set this vector scale offset. So main text here is the source. What do we do? Text chord. Main text scale offset. Yeah, because the UVs... Okay, this is going to be handy for us later down the road. Unfortunately, the problem we are having is not related to this, I think. So here we change the UV to be... Yeah, related to main text, which is the source texture. Although... Should be okay. Indeed. Yeah, this is going to be helpful later down the road when we want to actually apply the brush texture. We're not doing that right now. All we do right now is to get the affected pixels basically based on these variables. And I have double checked these multiple times. They should be correct, so should this one. Skulltag, he's been terraforming his code every day. Indeed, I have. What's up, Wesley? What the hell? Just got home from work Nice. It's going pretty good. It's going. So to summarize it, we have terraforming working on the CPU. Now I want to offload some of that work to the GPU, and that's where we currently stand. Doing it with Blit, but I can't seem to get the UV. Always this damn UV problem. Actually, we don't even need to send these in. I don't even know why I'm doing it. It's within bounds. What's up, Little Miss Murder? I hear you. Skulltag doesn't Blit use pixel coordinates? Don't think so. So Blit basically creates a quad, right? 4 vertices, each corner. And you get the UVs from that. This is out of scope of my brain. Same here. Yeah, we have some terraforming. We just have a problem of it being not. We're excluding a little bit of data based on positioning of the terraforming. So sometimes it works, sometimes it doesn't. Whoa. Here we actually got more than we bargained for. And now it's rather a problem of the other way around. The fuck? Still, I want to try one thing. I want to try multiple things, but... So here we actually got almost the correct result. We got one extra step in the both of the X directions. I have no idea what's going on here, yeah, I don't understand anything of that. Like, the problem we're having is we're trying to blit a small texture onto a big texture, but we only want to alter a specific set of pixels in the target texture, and that's the problem we're trying to handle right now. It doesn't seem we don't update the correct pixels. That's it. Like, we either get too few pixels or too many pixels. Yeah, we have the region created, and then when we check if a UV coordinate is within that region, that's where we fuck up, basically. So here we create a little bit of a region using a bottom left UV and top right UV, and that's what we use in the shader to check if the shader UVs, or the UVs passed to the shader, the main UVs, the UVs for the mesh, is within these bounds. Should be correct, should be correct, should be correct. This one seems to fail. I have no idea what panel beat vectors are. UV step size here. Is it a little bit too big this time around? Yeah, so we're getting a we're including the minimum value seems to be fine. We're including a bit more than we should, however. We're including one row and one column extra. Is that the case here as well? Yeah, it is. But actually here we're including two more. Yeah, that's wrong. Oh yeah, Little Miss Murder, that is exactly what we're trying to do. 100%. What the fuck? So basically we can also check for this one. Actually, let's see, yx so if we go here and then we do here, if we pause here, yx, and then we can double check what kind of UVs we have here. So for this one we have UV bounce start should be here, and it is. And then 1, 2 steps to the right and 2 steps up, which I think it is. Yes. So the UV coordinates and then we add one more. Yeah, let's see, was it here? Yeah, we're too loose with the inbounds check. In my opinion, you shouldn't be looking at your generated geometry, you should be rendering the height map. I get you. So basically what happens here is we get one extra row and one extra column in the negative direction. Which leads me to think that so we do UV start minus UV step size. We might get let's say that we get, yeah, because of precision, floating point precision, we might include the 0 as well here. The way I would solve this for tile overlaps is to make a scratch height map, copy the corners of the tiles here at the intersect of, modify the pixels of that, and then bleed it back into your height map. Yeah, I don't know if that's the problem we're at. So as I mentioned, like, we have this working on the CPU. Now it's just a matter of getting the UV coordinates communication, or to do the same work on the GPU, but with using a few other parameters. Like when it comes to terraforming, if we let CPU handle everything, we have like pretty much everything working. We have syncing between patches, recalculations of normals, like everything works. Now I just want to implement it, the height map alteration on the GPU, and compare the performance. Yeah, I think we're gonna name this one, let's see, UV step error margin. I also wonder if I'm also a little bit worried about like UV to pixel. We'll see. Okay, that works perfectly. That as well. Okay, seems to be working, I would say. Okay, that's nice. Okay, I think we have this part of the GPU terraforming working. Although, yes. The neighboring patch here gets included in the overlap box. when we calculate the UVs for that one, let's see. So it was like this, yes. Yeah. For performance dots, yeah, we have a lot of performance gains we can do. Yeah, combining all the patches into one big patch, yeah, that would remove the purpose, I would say. Okay, so this case. On the CPU we have the correct fix for this, but here we don't. Terraform data, do we only get... Oh, this might not be a problem with our solution at all. Let's see. We only have one Terraform data. Interesting. Little Miss Murder, the GPU doesn't care about your engine abstraction, but like we abstract it this way because the GPU does care. Devi, thank you so much for the follow, by the way. That's not at all what I'm telling you, Little Miss Murder. Okay, this problem boggles my mind as well, because the Terraform data, we don't even have these included in the Terraform data. Actually, We might. Yes. Oh, did we remove this one? Is within bounds. Okay, so this is the issue. Yeah, makes sense. Okay, the problem we're seeing here is related to the fact that we don't do one set of filter that we should be doing. But we should be checking if the Terraform data is within bounds. But then again, we also came to the conclusion yesterday that is within bounds here. It's done in the wrong way, but we're gonna add this one here now. Anyway, let's see what we have. Terrain patch. Oh, and then we create terrain patch terraformer. We're gonna add an additional check here. We might as well. Terrain patch terraform data, good. So we could do where terrain patch terraformer dot terrain terraform data is within bounds dot to list. So that should remove that issue, but it introduces another issue which I might show later on. And it has to do with our Terraform data having... It's pretty much out of bounds, but sometimes when it's out of bounds... it's out of bounds with a length of... a width of 0. And we want to include that width. So now if I do this, we get this. Okay. But then again, we still want to recalculate the normals here. Wonder. I think this is way quicker, to be honest. Yeah, so I guess what we actually want to do is let me show you the problem we're currently at. If we change this part, it changes accordingly. But so for this one, it's perfectly fine. We don't want to change the vertex position here as well, but we want to update the normals here because its neighboring vertices has been lowered. So when it comes to this patch, it's more a question of the marker is entirely outside of the texture range, so to speak, but we still have a case where we want to update the normals to avoid for a line like this. Okay. Thank you, Derek. Yeah, I think like every day we get one step closer to something amazing. Do I dare say it? I want to check. So if we remove this one, what's left to do? So right now, previously today we finished the terraforming on the CPU. Now we want to see if it's possible to offload some of it to the GPU and what gains we can get from that. So instead of altering the texture on the CPU right now, we're trying to alter it using Blit. Let's see here. Progress indeed. So if we do this, we unfortunately changed the height maps for these, but we actually just want to change the normals for we changed the normals here. We actually just want to change the normals for these points, so not the height map. So we need to have an additional check here. Interesting. But I'm gonna leave this in for now because can you explain a little about what Blit is? We can jump to this one. So it basically uses a shader to copy the pixel data from a texture into a render texture, or it can be used to just copy the value from one texture into the other texture. Because if you omit the material, Unity uses the default material. Okay, so it pretty much always take one texture, put it into another texture using this material. So in our case, our source texture is the brush texture. The destination texture is the height map texture. And we want to do it using a terraforming material. And that's what we're in the process of implementing. Blit, like, I've used it before for post-processing stuff, but in that case it's a little bit easier to handle, at least for me, because you usually work with a source and destination that has the same size. So pretty much, like, for each pixel in source, you want to do something for each pixel the destination. This is not the case this time around. Source and destination almost never, if ever, the same size, and source is usually much smaller than destination. Graphics.copy texture. I have not skull tag, or I have since it's purple, but I don't think we can use this, so I guess yeah, this. So graphics copy texture, the following must be the same in both the source and destination texture areas. Areas, however. Yeah, but that's still not true for us, I don't think. Left field question. Okay, I'm ready. The engine isn't modifying the bit data in any way, i.e. blurring it with bilinear filtering, for instance. When we read the data from the brush, it is, and I think we want to do it that way. So our CPU solution actually explicitly state that we want to use bilinear value, because our brush, for instance, might only be 16 times 16 pixels, but we're altering a 64 times 64 area. Yeah, so I'm a little bit worried about this one. I don't think we can go with this one. I'm referring to the brush. So yes, we do bilinear filter when we get the values from the brush. Too bad indeed, skull tag, but I also, so this is the main thing, but I think it's actually going to work out for the better in our case if we use a custom shader here, because we can do a lot of stuff in this shader. And copy texture. Yeah, we lose a lot of flexibility. I guess we could. And this just basically just copies it, right? It doesn't alter it in any way whatsoever. Because if the brush is being mangled, you're chasing your tail trying to figure out why the tessellation isn't correct. No, it's like... It shouldn't be altering it in a way that fucks it up for us. I think that's the bottom line. It's just gonna do some interpolation for us, so that we get a little bit of a smoother result when we use different brushes. Like our current implementation of the GPU approach, but you're applying bilinear filtering to it. Yeah, like as I said, our brush might be 16 times 16 pixels, but we're altering an area that is 32 times 32 pixels. So there you got two choices. Either you don't filter the brush, which means that you will affect neighboring pixel with like you will have more of a truncated value change in the result, or you do bilinear filtering on the brush and you will get a more smooth result, like, right? How deterministic is it? How does it behave on the edges of the patches, on patches? There you might have a point, actually. But nah, it should be okay. It should be okay with the current implementation. But thank you for that note. I'm going to keep that in mind. Like, the idea is when we alter the same height map data for different patches. So if we have a marker that is overlapping two patches, so we have the first column of one and the last column of the other, the actual variables we send into whatever solution is recalculating the height map should be the same for them. Like, it should be based on, yeah, it's based on world position, and so we're pretty much altering height maps at the same world position. And since we base the altering properties of the world positions, it should be the same. Like, it should work similarly to how we generate this. So when we generate the patches, we create textures using Perlin noise per patch, and the patches don't know anything about each other. Like, the height map generation don't know anything about its neighbors. But since we're using the world position as seed and they have the same world position, we get the same values. What I'm suggesting is that you remove the patches abstraction before you let this GPU deal with the terrain mesh, stitch them all together into one big patch and then feed it to the GPU. It's a pipeline ordering issue. But it won't. You're trying to force the GPU to take into account your patches. No. No, I'm not. I'm not forced. The GPU doesn't like the patches, the height maps on the GPU. They don't know anything about their neighbors. Not at all. We actually have one solution where we stitch them together, the height maps. Unfortunately, didn't work as good as I would have hoped. There shouldn't be any neighbors to begin with. I think it should be. Like, why don't you think there should be neighbors? On an engine level, yes. For your terrain generation. Yeah, that's what I'm trying. Yeah. The only thing the neighboring is used for right now is to recalculate normals. But before you let the GPU deal with the terrain spline map, you stitch it together. So what you're saying, every time we want to alter one patch, we stitch it together with neighboring patches and then send it to the GPU. I don't know. I don't know. Wouldn't that result in an extremely... Yeah, that sounds really slow indeed. So you want to stitch them together on the CPU? I'm skeptical, but I'm always open. You only need to deal with the area of interest. To be honest, like doing it that way sounds like an abstraction to make it easier to work with, not more performant. You have to do it anyway every time you terraform. No, I don't. No, I don't. I'm listening, I'm taking notes, but I think I'm a little bit skeptical. First of all, spline map. Are we talking about the height map when we say spline map? And why are you regenerating the spline map if you're not terraforming? Like right now we are debugging, so we're right now we do that. Like the idea is we blit to the certain pixels, then we read back the result just to the specific altered height map pixels, and then we change the vertices of just those pixels. Spline map, the tessellated result from the height map. Let me keep that in mind. And if you have any write-ups on similar stuff, I would greatly appreciate them. Like that goes into depth a little bit more what you're trying to convey. Well, if it were old-fashioned OpenGL, it would make more sense, I guess. Like the initial idea of having them patched up is that you, for a lot of reasons, basically, you could LOD them separately, And if you alter one, it's like if we alter this height map, this part of the height map, we don't need to alter this one or this one or this one. I don't know. Monochrome height map, geometry cached, feed to GPU. Terraform is equal altering the pixels of the height map, regenerate geometry. Yeah. What I'm missing is why you're forcing the GPU to deal with this distraction. I don't force the GPU to deal with that distraction. Like, the GPU doesn't know anything about the patches. The GPU doesn't know anything about the neighbors. Like when we do terraforming at an edge here, we basically do terraforming to dispatch, terraforming to dispatch, terraforming to dispatch, and then terraforming to dispatch based on the rectangle we have. So they don't know anything about each other. The only thing they know, the only thing we feed to the GPU is a rectangle. You should, like, hey, change these height map values based on this rectangle or based on this boundary. That's all we do. That's all we do. Okay, let's see. So we have this blit here. Right now we read the full data, the full height map per patch after a change. We just want to read the affected pixels. So we should be able to do this and this. So blit based on this, whatever information we have here. And then read the pixels to the CPU here. And you mentioned you tried stitching the patches height maps together and generate a single tessellation. No, we stitched the height maps together, so we were working with one big height map instead of multiple small ones, and then we were still generating the terrain as patches. So when we told the GPU to render the geometry, we told it to just use a portion of the height map. Okay, let's see if this works. The problem with this one right now, let's see. What do we get here? Yeah, the problem with this one, with the current implementation of the Terraform shader, we change all pixels. We're going to rely on an alpha blend here later on. Some type of alpha blend. Wonder how well it will work with negative values though. So the idea is basically from this shader we output the height map change. Nah, it should probably work. The height map change, and then we let the blend commands handle how they're being added together. But the only thing this will do is okay, we're not reading the correct values back. Or actually we are. We are, but okay, let's see what we can do with the blend. Let's go Unity. What do we have? I guess this could work if we only wanted to heighten. Yeah, the problem is that sometimes we want to subtract and sometimes we want to add. So source alpha 1 minus source alpha. We're gonna have to rely on different blends based on if we add or remove. Would like to avoid that. Definitely would like to avoid that. But if we do, just for testing purposes, if we would do what is it here? So if we would be doing this, and let's see here. Perlin noise texture generator, we generate them with a value of 0, so our The default terrain is at 0 height. And our terraform shader here then. So we just do, so if it's within bounds, we return 1, 0, 0, 1, and here we can return 0, 0, 0, 0. So we take the source alpha, but, oh, that's true. Yeah, I wonder if we want to rely on do we just want to do 1, 1? So we just add them. Then again, so if we're within the bounds of the rectangle, then we add 1, otherwise we don't add anything to the height map. Yeah, let's start with 1. So the result I want to see now, when we terraform a rectangle, we just add 1 height to it. So we set it to maximum height. Although once again, yeah, we should be reading the correct pixels back. And then we will alter all the vertices currently. How long have you been working on the terrain so far? By the way, ooh, good question. Started in, so 1 month, I think. Yeah, that's about it. Good amount of time indeed. Okay, so it does actually work. But we're reading back the wrong values. Is that how I'm going to... And then we have this issue still. Okay with that. So the question is, we do change the correct height map values. When we read it back, what am I doing wrong here? The render texture is the source. The render texture should have the same width and height as this. Honestly, should be the correct values. We alter certain pixels in the height map by 1-1 blend, and then we'll read back those specific pixels. That's the idea, at least. Okay. Okay. Very weird. But before I dive into that anymore, I just need to run AFK real quick, so I'll be right back a couple of minutes. Okay, back. Let's see if we can get this under control before I have to quit for today. Like so many other things concerning this, I don't know, like I can't directly see why this one wouldn't work. Could it be now I have to remember that data render texture has the same width and height as data, so fetching XY width height from render texture then from the source. So active render target is the destination texture, i.e. data render texture. Skulltag having fun? Actually, yes. This whole adventure has been one hell of a learning experience, that's for sure. But, like, most of the problems, if not, like, the big majority of the problems are always related to, like, indice differences. We're working with a lot of different indice types here, to say the least. Like, if we do this, so here we basically just read all the height map data, or all the data render texture data, and put it into our height map data here, then it works. But when we try to just read the affected data, it does not. Bottom left clamped, yeah, that's what it should be. Bottom left clamped Y. Size clamped XY, yes. Although I wonder. Yeah. Okay. probably not something that could disrupt the current implementation. Although data render texture. I wonder if, like here, this pretty much implies that we want this render texture to hang around, and that might not be the case. What's up, Rosary? How about creating a temp texture by copying the surrounding pixel of interest around where the brush is about to terraform, i.e. combine the height maps of affected patches, then modify that using the brush, and then splitting the temp surface back and overwriting the original patch height maps. We'll see. What's up, Fabic? Hope you're having a wonderful Friday. Okay, so what I'm wondering here. I'm doing good. Thank you for asking, Fabic. How about you? I'm a little... Yeah, we might not want to rely on this one always being around or being synced with the data. But... So what we could do... Fabic just woke up. Damn. Stayed up late programming, I guess. So, yes, indeed, nice. Hope you made some wonderful progress. Little Miss Murder, I'm not totally against that idea. Rosary, just ask, it's okay. Although I'm not that familiar with VS Code, to be honest. So, Little Miss Murder, okay, first of all, I'm gonna do this. We're not gonna rely on a data render texture that we create once and just hope it stays around. Instead, we're gonna do Is this all we need? Did I put 0? Should be released, should release it accordingly. And I wonder if I want to do this, to be honest. And we might not want to rely on blend here either. So if we do render texture, data width, data height, put it to the render texture, then we read it back. This one is empty for now, so we're gonna have to fix that. We're working on terraforming still, trying to offload some of the work on the GPU. Render textures don't just disappear if you make them in code yourself. but the contents can become lost. At least as when loading new levels, system going to screensaver mode, etc, etc. Right? Emo, your biggest blocker is that you don't know how the brush behaves on patch edges. Have you tried duplicating the brush operation of that? Like we have different brushes working on patch edges if we do all the calculations CPU. I don't think that's the problem. If we replicate how we do it on the CPU but we do it on the GPU, it should be okay. I had some problem with render texture content being lost when I did my outline shader, I remember. But that I thought that was because of like how I fetched the render texture in question. So, but I don't know, like, sure, the contents can become lost, but in the examples they have here, it's pretty rough stuff, pretty specific type of things, right? Loading a new level, yeah, we're not doing that. System going to screensaver mode, I don't think it has done that. In and out of full screen, maybe. You don't know. But, big but, Little Miss Murder, you said the GPU doesn't know about the patches. No, it doesn't. And so doesn't the CPU when we do height map changes. Rosary, thank you so much for the follow. As to the question, I have no idea what's going on. Okay. Isn't VS Code for Java? It's for anything. Render texture. Okay, let's just say that we create it like this. Then we blit to it, then we read from it. Feels like we're gonna do a lot of trash here. Big question here if we can do The question is how these UVs are based though, but it should be okay. Let's try it. I think it's okay. Let's just make this to make sure actually. And then we do data. And create the render texture, blit to it, read the pixels back to data, apply the change. Minus yeah, I think it's nice so far, Fabric. Thank you. But yeah. A lot of question marks here. A lot of question marks. Killazaur, thank you so much for the follow, appreciate it. A lot of... yeah. I don't know. I don't know about this at all, though. Or actually... oh, yeah. Never mind, yeah. We return 0 here, then we bring it up to 1 or 0.5. Hmm. So now we're at 0, right? The terrain. Yeah. We don't do anything there, we don't do anything there. I missed the Perlian noise part of the landscape, me too. And I missed the CPU implementation of the terraforming. I don't know, I have 0 idea what the fuck is going on. Nothing seems to be doing what I think it should be doing. What I want it to be doing. I guess we honestly could do... Yeah... So... Yeah. Yeah, the error definitely lies within this shit show here, I would say. The current GPU solution, that is. Or not. Yeah, what the fuck? Am I tired? Or am I tired? Let's wait to the end with releasing this one. Okay, great job. Alter the render texture, release the render texture, and then try to read from the render texture. Yeah, this should be one step more correct at least. Okay. Yeah, we have that issue with the GPU solution, but I don't care about that right now. Yeah, so as soon as we read all of them, we get the correct. Have you tried drinking to solve the issue? I hear it solves many problems. Yes, so I've heard as well. Unfortunately, it also creates other problems. It's a lot like fixing bugs, you know. You solve some problems and create new ones. So the blit works, the readback of the pixels does not. The region of the render texture to read from. I don't see it. In what world? Come on. Bottom left clamped, X, Y. Programming is creating solutions to problems you thought you will never encounter. Yes, indeed. Sometimes it be like that. But this one bothers me to no end. Top right clamped minus bottom left clamped. Yeah, that should give us the size clamped. And like yeah, let's see here. The problem is this blit works. Like we alter the correct pixels of the textures, or correct pixels of the render texture, but then when we want to read the data back to the CPU, like when we want to read it back, if we read all the data back, so if we take this full render texture result and put it into data, then it works. But I want to only read the part that we have actually altered, and that does not. Terraform bottom left clamped should be, this is pretty much how we set the pix. This is how we do it on the CPU. And here we use the same, although here you set a length. Or you set an array here. Yeah, let's although we can break it down. I'm just gonna read pixels. Do we have any constraints here? Yeah. Find it extremely weird if this would be 0. So they still want to force me to do let's see, which one do I want to use? New render texture. Okay. Width, height, depth, render texture format. Render texture format. could this be the problem? Okay, let's do this. Yeah, and let's do 0 here. Let's jump over to Terraform shader, and what we do here is we just return float 4 1 0 0 1. So for all pixels we return 1 in the red channel. And then we try and make a partial read back. Actually, let's do it like this and see what we get. So Blit changes maybe. So Blit changes, like, we create a render texture and then we set all the pixel values to 1 in the red channel, and then we read a portion of it back, hopefully a portion within the marker. So the whole height map should change to 1, but we should only read back within the marker. Okay. Okay. The weirder it gets, the more time I spent on this. Okay, so read back the full texture, but only change the pixels within. How can I manage to change that? But only read back, but only change the pixel within the marker. Like, if both of these works separately, they should be working together as well. I don't get it. Что? Or are we, let's see, compiling. Okay, yes, I wonder if we just unfortunately skipped a, like if the compilation stage got skipped for some reason again. Okay, so now we're working with something. So the full terrain patch should be altered to 1. We should only update the correct ones. And yeah, we can see here that it doesn't work. Okay. only works in yeah, and we don't do apply. One patch setup. Yeah, we could do it. I don't think it should be related to the one patch though. But we could probably check it. It's a problem with the readback, but also Jesus, yeah. It's 100% this, but I have no idea why. Or honestly, it could be I think we double checked the nodes previously. Let's take a look. Honestly, I wonder if it's is it a difference in how render texture is stored and stuff like that? So if we take a look at this one, so we have this marker right here. Debug. So the Terraform data we have for this marker is we have a bottom left clamp is at 1.1, and that's correct. So we have here, and bottom right clamped is 3.3. So that's 1, 2, 3 here, and that's correct. Although, yeah, I appreciate it, Fabic, and of course, it's no problem at all. It's nice just to go back and double check. But yeah, like bottom left, bottom right seems it works. Like we have the correct data in Terraform. If we take a look at size clamped, we have 2, so 1, 2, that's also correct. And vertices and height map has the same dimensions. Yes. Yeah, it's weird. Actually, size clamped is 2, so 1, 2. That's the number of steps, but when we make it from a rectangle, we want to add 1 to that, which we do, because we want to go 1, 2, or yeah, 1, 2, 3. Pretty sure they count the initial one. Yeah, they do. So an example, we have screen width, screen height here, yes. Could it be... Oh, maybe. I don't think it should be. Yeah. Like, what the fuck? Is it stored in like column first? And the other one is stored in... It shouldn't be. Big question mark. Have you tried just hard coding one fixed position adjustment and see where it happens in the world? No. Render texture, constructor. What is default? Honestly, what, like, this works, this does not. Yeah. But I'm betting on that I'm gonna feel quite stupid when I get to the bottom of this. Unfortunately, I won't have the time today. Because I gotta run. Is this gonna bother me for the full weekend? Probably. I wonder if there's some, like, coordinate system mismatch between them. It just boggles my mind even more that this works. But yeah, unfortunately, I guess we're gonna have to return to this on Monday. And yeah, probably test it thoroughly with some smaller values, because I gotta go. But slow progress today. But still progress, I would say. Thank you for watching. Terraforming Sea, indeed. So, as always, everybody, thanks so much for watching. Appreciate it. And have a great weekend. Peace.